Today on Coding 101, we have for loops, if-then statements, and mod.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Coding 101 is provided by CacheFly at CacheFly.com.
This episode of Coding 101 is brought to you by Squarespace, the all-in-one platform that makes it fast and easy to create your own professional website or online portfolio. For a free 2-week trial and 10% off, go to squarespace.com and use the offer code CODING. Welcome to Coding 101. It's the Twitch show where we introduce you to the wonderful world of the programmer. I'm Father Robert Ballecer.
And I am Shannon Morse. And for the next 30 minutes, we are going to get you all coded up on everything you need to know about Python to become a code warrior.
That's right. Now, you know, Shannon, last week we talked a little bit about loops. Now, we know from the C# module that loops are an absolutely necessary part of programming. Absolutely.
They save you a lot of time.
Yeah.
So I decided to go ahead and do a very, very simple loop from my example this week. And it basically is what you taught us, except a little bit more complicated, just a bit. So I'm going to pull up my loop real quick. Shannon loop example 14, and I'll show you what it output looks like.
Boom.
So it simply says up at the top,
that's a lot
let's
of
do
numbers.
some math. And you'll notice over here it increases from 12 to 14, 16, 18, all the way down until at the bottom it gets to, whoops, way too far. It gets to 100. Press enter to exit.
So you did an increment by 2 instead of the standard increment by 1.
Exactly. And I started my number at 10. And I also added the print at the beginning that just said, let's do some math. Now, we also figured out that if you're doing this in idle on Windows and you have a while number and then whatever, and it ends with a colon, it will automatically do that indent for you. So you don't need to tab over anymore because it'll just, it'll just save like that. So it gives you a little bit of extra functionality whenever you're using idle. And I like that. I didn't know about that before I did this loop. So it's very simple, very easy to use, and it's a good example.
And something else about this I think it's important to point out is, so you did the while loop. And remember, in Python, white space counts.
Yes.
It's not like C# where you could actually crowd everything together, and as long as you end each line properly, it's all good. In Python, it's important where you put the lines. And if you look at Shannon's code, she indented the code that went under the while loop. Exactly. Now, at the end of that condition, remember, the condition is determining whether or not the loop is going to continue to run. In this case, it's number less than 100. She puts that colon there, and then everything that is indented after the while loop will be part of that while code. In this case, while she's adding another line of code, that second while
indents for you.
Exactly.
So cool.
It automatically indents, and once you bring a line back to the start, it's no longer part of that code block that gets looped.
Right. So very simple to do again, and I really enjoyed doing that. So I'm going to go ahead and close that. We also had a couple of user examples that I enjoyed checking out this week. They're a little bit more advanced than what we have been showing so far, so there's a couple of things in here that you might not understand yet, but we will get to those. The first one is a simple tic-tac-toe game, and I'll go ahead and open this so you can see what it looks like when you play it. So it says, welcome to tic-tac-toe. Player 1's name, do Shannon. Player 2 is going to be Padre.
Oh, I hate tic-tac-toe.
All right, so my move, Shannon.
Nice.
Okay, I'm going to choose 9.
6.
6. Okay, so we have 1x, 1, 0 there. My move, I'll do 1. Okay. 3. I think I'm going to win. Let's see, 7.
Oh, well, no, I'm not winning this time. 4. What? I'm going to force you to win.
X, or 8.
There
Yeah, 1. All right, so, very simple to use. Now, if we look at his code...
this is actually a nice piece of code. So we've got input,
it's clean.
We've got graphical output, and we also have state checking, because it has to check to see if one of the players has actually won.
Exactly. So here we see that he's printed the tic-tac-toe board game right here. And he's named each one something different. Board 9, board 6, board 3. So he has each one named differently.
In an index.
Yes, exactly.
Right. Nice.
So a very easy way to tell each space apart. And then if we go down, he has a bunch of if statements. If board 2 equals test and board 5 equal test,
right.
and board 8.
So in this case, what he's doing is he's checking all the possible ways to win, and he's seeing if all of those states are the same. If they're all the same, either that 0 or the X, then he knows that one of the players has won.
And then if we scroll down, you'll see, so this is where the game starts. So depending on whether one is a 0, one is an X, it'll determine who is winning and who is losing. And then it'll trade back and forth between the two players as you continue to go down.
This is actually a brilliant piece of code because it shows you, again, taking something as simple as tic-tac-toe. And as we all learn from war games, it's the game that's going to teach the computer how to be sentient. But it allows us to really look at what you need to do to break down logic into something that a computer can understand. I say awesome, fantastic job.
And check these out. We got a while loop. Ha, awesome. I love that he included the while loop in there. So here we have the player returns, and then who wins the game, and then if it's true or not.
Yeah.
So it's kind of complicated in a way, but when you read through the code and you take your time to actually look at it, it makes complete sense. Very, very interesting, and I like that one a lot. And this one came from, if I remember correctly, that was from Scott. Now, we also had one from Jerry that I wanted to include as well, and I'll pull up this example. So this one just asks you for a number. So if I give it a number, I'll say, let's do 16. So I'll hit 16 and then enter. The number you entered is 16. Factor is 1, factor 2, 4, 8. So the list of factors is 1, 2, 4, and 8. Interesting, huh?
I like that. Well, and again, it's one of these programs that it asks for some very simple input,
15.
and then it gives you a calculated output. I like that. This is really what computers were made to do really quickly the calculations that could take us a little time to do in our heads.
So this one's doing math. Yay! So it's basically doing determining factors of a certain number. So you can type in any number that you want, and it'll give you the different factors of that number. So it gives you a factor test number, and then he includes all these really, really important notes in here as well, so you understand everything that he's doing as well. Very interesting. He has some if and then, or if else statements in here, and he also has a for loop. Pretty cool. And his is a lot more short than the other one. But also, again, he included those notes and those comments, so it keeps it very understandable. It's very easy to understand what he's doing in here. I'll go ahead and close that one.
Thank
so
you
those are my examples
Jerry.
This week. Yeah. Of course, if you guys want to share your examples, you can always do that in our Google Plus community. You can search for Twit Coding 101 or go to gplus.to/Twit Coding 101 to do that.
And folks, let me stress that, if you want to submit an example to us, it doesn't have to be super, super complicated. Obviously, Scott and Jerry have some Python programming skills. Obviously, they've got skills as programmers. But if you just want to show us the thing that you did, just, your first time out, that's got as much chance as being on the show as something like tic-tac-toe or a factory program.
I love it when people share their first code ever. That makes me excited because, I'm very new to a lot of these languages as well. And I've been sharing my beginner code. Of course, a lot of these are very advanced and they're cool, but I love seeing what you guys are beginning to do. So please do share them.
And we want to stress that this is a learning environment. It's Coding 101. This is not advanced, super advanced coding for AP students. This is designed to get the beginner in there, to really give you an opportunity to jump in the community, post something up, and let people suggest things to you. That's one of the things I love about our G+ community, which is we got people in there like Joe, who will say, hey, that's nice. Have you tried doing this? Or have you tried adding that? It's part of the learning experience of just hacking around with code.
Now, I believe that you have some information about websites.
Yeah, so, Shannon, I was just thinking, I want to create a website, right?
Okay.
But I'm just so bummed out because I know that if I want to create a website, I'm going to have to worry about the back end. I'm probably going to have to
code.
I have to know code. I'm probably going to have to hire someone to do my registry. I'm probably going to have to hire someone else to do the hosting, and maybe even a third person who can figure out all the database stuff so that my WordPress blog works well. I want to do it, but
it gets so complicated.
It gets complicated. If only there were a way that I could bypass all that stuff.
I wonder if there's a way.
You think? You think?
I think there might be.
What's that thing on this? Is that Squarespace?
Squarespace.
Oh, I've heard about, yeah, Squarespace. I've heard about Squarespace. Now, you should have heard about Squarespace too, because they are really the all-in-one, the one-stop shop for you to get all your registry and hosting needs. They are the ones who make it easy to create your own professional website or online portfolio. Now, I have actually used Squarespace personally. In my previous job, when I was still living in DC, I always had to set up blogs for churches, blogs for schools and universities. And honestly, sometimes those organizations don't have all the people they need to keep up a blog, something that you actually have to program on your own, that you have to worry about maintaining. So I turned them on to Squarespace because I said, look, use this service. They'll do everything for you. They'll take care of the database. They'll take care of the updates. They'll take care of your bandwidth. They'll keep it up at all times. All you have to do is focus on creating some wonderful, wonderful driving content. That's really what Squarespace is about. Now, Squarespace is constantly improving their platform with new features, with new designs, and even better support. They also, by the way, have those beautiful designs, 25 of them, beautiful templates that allow you to quickly build your own personal or business site. And you get to customize these designs, which means that you're not going to have a website that looks like 1,000 others. You're going to have something that is really, really tuned to your audience, to your content, to your likes and your dislikes. One of the other things I really like about Squarespace is they have a pure mobile experience. You may notice this on some websites, typically WordPress blogs that haven't really been optimized for mobile devices. You get the full-size blog or web page on your tiny little screen. It just never looks right. Well, you don't get that with Squarespace because they build those smarts in. Squarespace will know if someone's watching on a laptop or a desktop or a tablet or a phone, and it automatically adjusts the format, the size, and the design to make it look right. In other words, they're ready for the next generation. They're also really easy to use. This is one of the reasons why I can turn on some of my, say, lesser tech-inclined clients to Squarespace. Because if you want help, Squarespace has live chat and email support 24 hours a day, 7 days a week. Plus, there is a completely redesigned customer help site for easier access to self-help articles and video workshops. They also include hosting. This is what I was talking about at the beginning. I don't want to have to pay one vendor for this and one vendor for that and a third vendor for the third thing. It's all in one place with Squarespace. And it starts at just $8 a month, including a free domain name if you sign up for 1 year. Now, even their code is beautiful, and this is why we like having them on Coding 101, because we don't want one of these vendors who uses an off-the-shelf WYSIWYG editor that may look okay, but if you actually look at the code, it's just a mess. It's not so with Squarespace. I like to peek behind the curtain, and what I've seen with Squarespace is code that is as elegant inside as it looks outside. Squarespace even has a developer platform if you really want to dig into site customization, and developer accounts never expire while in development, which means you can take as much time as you need before launching your site and pay nothing until you go live. In other words, if you're not trying Squarespace, well, what are you doing? Now, this is developer platform feature, so I think it begs us to talk a little bit more about them. The first thing is that they allow you complete control. You get to edit all the code that affects the display of your website. Every single line of HTML, CSS, and JavaScript is under your control. Yeah, you get to use these templates, but you also get to modify the things that make your site go. That's something that every developer really wants. Even if you're not going to take advantage of it, it's nice to know that it's there. They also have Git integration as well as SFTP. Every template is a Git repository. Version control comes standard, which means you can connect it to templates via Git or SFTP and allow a group to go ahead and jump into the development. Now, their developer tools also include less pre-processing, JSON templating, script comboing, Retina-ready responsive image handling, and so much more. So the bottom line is we want you to try Squarespace. We want to see if maybe they are the solution for your next project. Start a free 2-week trial with no credit card required and start building your website today. Now, when you decide to sign up for Squarespace, and if you're serious about your content, I'm sure you will, make sure to use the offer code CODING to get 10% off and to show your support for Coding 101. We thank Squarespace for their support of Coding 101. A better web awaits, and it starts with your new Squarespace website. What do you say, Shannon? Want to do some ivory tower?
Oh my gosh, I do. I'm so excited about this.
Fantastic. All right, so last week, we talked all about while loops, right?
Yes.
And you demoed them, and so you brought them back.
Yeah,
and
very simple.
Very simple, right? And more than that, it's really the same as what we saw with C#. While loops, they almost work exactly the same, right? You have a counter, you have a condition that says whether or not you run the loop, and you have a block of code.
Pretty much the only difference is how you write the command.
Exactly, how you write the command and the syntax. You know, again, it's that white space versus ending each line with a semicolon. Well, we're getting to for loops, and although they work pretty much the same way as for loops in C#, they are a tiny, tiny tad different in the way that you create the loop at the beginning. Now, so when we did for loops in C#, we always had to make sure that we set the beginning value for the variable that does the condition, right? Whether or not the for loop runs. And then we also had to make sure that we incremented.
Right, that's true.
Because if you don't increment or decrement the counter, then the loop will either always run or always not run.
That's correct. Yeah, I remember that.
And so we had to always make sure we built that into the code. Well, the same thing holds true for loops in Python, but the way that you increment or decrement are slightly different. It makes you change the way you think about for loops. Now, let me show you exactly what we're talking about here. Let me pull this up. This is what the code looks like for a for loop in Python. Now, you'll notice that this is about as simple as I can make this. Now, for counter is the variable. So it's the expression, right? Is it true or false? But in this case, it's going to say for counter, and then we have a function in range, and it passes 2 parameters.
Okay, and so for this loop named counter.
Well, for the loop with the counter called counter.
Right.
Range 0, 3. And what that's going to say is it says for this range starting at 0, ending at 3, print counter.
Ah, okay.
That's what that means. Now, what's unique about this is we predefine the range that the for loop is going to run. It's all right here. We know exactly how many times this is going to run because we can spell it out.
Okay.
Now, you got to remember that a for loop in Python is going to be a pre-check, but a post-increment decrement, which means it's going to check it at the beginning. It's going to say, is counter in range of 0 to 3?
And if it is, it prints it.
Yes, and at the end, it will go ahead and add to the range.
Oh.
So it's going to start it at 0, and it's going to say, well, is 0 in range of 0 to 3? Yes, go ahead and run that. It's going to print 0. Then it's going to say, well, we increment that from 0 to 1. Now it's going to ask, is counter 1 in range of 0 to 3? Well, yes, it is.
Yes, so it prints it.
Exactly.
So it automatically knows that you're going to increment by 1 for this range.
Right, exactly. So it just kept incrementing until we get to 3. It's going to get to 3 after it prints 2, and then it's going to say, is 3 in range of 0 to 3? And it will say no.
Really?
3 is not in the range. 3 is the upper limit of the range.
The end of the range.
Right. So if I'm right here, when we run this, what it should do is it should show us output of 0, 1, and 2. And there we go.
And it does.
That's what it does. So that's how the for loop runs. Again, it's not super complicated, but Python, it demands you think a little bit differently about how the for loops run.
It's kind of weird that it still prints the 0 at the beginning and not the 3 at the end.
Yeah. And again, you know, these are those things that they change from language to language. This is just how Python happens to handle a for loop.
So why would you use a range?
Well, like if you use while, we love using while for menu, right?
Yes.
Because we can make it indeterminate. We say keep running this until they want to exit out.
Right.
You'd really want to use, in this instance, for Python, you'd want to use a for loop when you have a determined range. You know exactly how many times you want to run this thing. For example, let's say we have an array and we want to fill the array with values. Well, we know exactly how many values are going to be, so we can have a range for all those values.
Yeah, okay, yeah, that makes sense, cool.
Yeah. Versus,
that's a good example.
Versus a while loop, which could run forever.
Right.
Yeah.
Okay.
All right, so that's what we got. Now, we're not just going to do for loops. For loops are great, and you know they're a necessary part, but we're doing more? We're doing more, M-O-A-R.
It's going to be a complicated show.
We got to talk about if-else statements.
Oh boy.
Now, we got a little bit of that last week.
I was looking forward to this.
Yeah. Now when we talk about modeling the real world after, inside of computer code, if-else statements are a huge part of it, right?
Yeah, that's true.
Because an if-else statement allows us to convert things into that binary thinking of a computer, 0 or 1. Is it true? Or is it false?
Right.
And quite simply, an if statement will just look at an expression. It will say, is this true? If it's true, run this code. If it's not
true, don't run the code.
Skip. Right.
Or skip it.
Right.
Yeah.
So this is what an if statement looks like in its very simplest form. If you could go ahead and go to my computer, I've got 2 inputs here. I've got raw input A, I've got raw input B. Now the first one says, please enter a whole number, and then the second one says, please enter a second whole number. I'll see that up on my screen. Now it's going to do a simple comparison. Is A less than B? Okay,
and if it is, it prints out A is less than
right.
B.
So if I run this, I'm going to say, okay, my first number is 2, my second number is 4. Oh, yes, 2 is less than 4, which is all true, right?
So run it again. I want to see what it does if you don't.
Yeah, exactly. So let's do this. Let's go ahead and jump back and run it again. And this time we're going to say 4 and 2. We reverse it, right?
Right. Nothing.
Nothing.
Okay, cool.
Okay, so we got to that if statement. We got to the part where it was doing the relation, the expression, right here, and it said, oh, no, 4 is not less than 2. So it didn't run this. But
so it doesn't compile any kind of output because you haven't told it to.
Right. So I could put a bunch of if statements, but there's actually something built into the if-else statement that doesn't require me to do that. So I've got this. I can put if, I can put elif, and then else. This gives me 3 different options, right? So I could say if A is less than B, or else if
that's what that
A is equal to B.
It's like, was that a misspelling?
Yeah, no, that's else if. Or else.
Okay.
Now, I could also leave out, if I just had 2 options, I could leave out the elif. I could just say, if A is equal to B, then print this, else, which means any other condition, print that. But in this case, I want to have a 3rd option, right? I want to know if A is less than B, I want to know if A is equal to B, and I want to know if B is less than A.
Okay.
Right?
Yeah, that makes sense.
Okay, so now if I run this.
Else, if, elif.
Elif. Now, if I enter a whole number, let's do the 2, 4. 2 is less than 4. Let's go and run it again and switch that around. 4 and 2. You know, it actually, so now I'm doing that, that last bit, right? And then let's do the one where we actually have the same output, or the same numbers. So let's say 5 and 5. 5 is equal to 5.
Oh, cool.
And again, you know, this is all about a decision tree. We want to make a decision tree that runs through the problem that we're trying to figure out, which is the first number, what is the first number in relation to the second number?
Right, okay. So you're always checking it against a second variable.
Yeah, yeah.
Awesome.
Cool? Does that make sense?
It does make sense.
Okay. Now, there's a few things in there that we brought it from C#. If you want to know about relational expressions, just go over to C# because they're the same thing. We have greater than, we have less than, we have greater than equal to, less than equal to.
Okay, so we can still carry over all the same ones.
We can still carry all those. Okay. Not equal to or equal to. Actually, equal to is, remember, the double equals. That's a relational expression. All right. So that's our if-else statements, right? There is one other thing that I really want us to cover, and that's mod. This is a little teeny tiny thing that we want to cover. Mods, modulo. The idea is we do a division. So let's say I do 2 divided by 2.
Okay.
Okay?
Yeah.
Oh no, let's say 10. 10 divided by 2, right?
5.
I get 5. Right. What's left over?
5.
Well, no, I mean, so what's the remainder of a 10 divided by 2? It's actually 0, right? Because it goes in perfectly, right? Yeah. Now, if I did 11 divided by 2, I get 5, but then I also get 1 left over.
You have 1 left, yeah.
Exactly. So, and if we think about it, if I were trying to come up with a program that would determine whether or not a number was odd or even, I could use that, right? Because if I mod something, if I mod a division by 2, there's only 2 possibilities. Either there will be nothing left over, which means that it's even, or there will be
something left over, which means that it's going to be odd,
it's obviously. Going to be odd, right. So it's either 0 or 1. If it's 0, it's even. If it's 1, it's odd.
Well, that's cool.
Right. So
that's a modulo?
That's a modulo, which we write like this. So if you go ahead and look at my code, again, we input a whole number. We asked them to input a whole number. Now, you'll notice here that I went ahead and did a check. I made sure that the variable that they entered was going to be turned into a number, right? Because I want to do math here. Now, here's what it looks like. This right here, this %, that's the modulo. That's a mod. So I'm saying a variable called leftover is equal to variable 1 mod 2. So variable 1 divided by 2, the leftover is going to be put into the variable called leftover.
That totally makes sense, and you're using the if-else.
Right. So if variable 1 was 11 and it mod 2, 1 will be left in the leftover.
Right. So it's going to say is an odd number because it's not equal to 0.
Exactly. And that's what this does down here. So if leftover is equal to 0, then we know it's an even number. Now we also know
is an even number.
Exactly. We also know that with mod, there's only two possibilities. It's either 0 or 1. And so we don't have to do another if. We just know if it's not 0, it's got to be 1. And so therefore we know, go ahead and say it's an odd number. So let's go ahead and run this just to make sure that I didn't mess up this code too. So give me a number.
Let's see, 46.
46. And 46 is an even number. That one was too easy.
True.
Go ahead and give me a big odd number.
Big crazy one? Okay.
Yeah.
465,324,655.
There we go. Ta-da.
It's an odd number.
It doesn't matter how big or small the number is. It's very basic math. You mod anything by 2, you're either going to get a 1 or you're going to get a 0, which will give you your odd or your even.
That's pretty cool.
Yeah. And now, what I like about this is not just because the code is really, really simple, but also because the math is really, really simple.
Yeah, it is.
And this is ultimately what we want to do when you're programming. You want to break it down to the simplest math possible.
Okay.
Because, you know, big, complicated math, it's fun, but where you really get the work done is when you can break it down into the tiny bits and pieces to get stuff done.
Oh, absolutely.
Yeah.
Make it easy.
Make it easy. Now, we want to take all these concepts and we want to show you how they actually work in code. Ooh. So, what do you say we bring in our code warrior?
I think we should.
Ladies and gentlemen, it's Dale Chase. That's right,
Yay.
from Discovery Digital Networks. He is our code warrior. He's the man with the plan for Python. Now, Dale, I mean, we're covering some basic stuff right now, of course. We just covered some for loops. We just talked about if-else statements. We talked about mods. If-else statements, I mean, you basically don't have programming without if-else statements, right?
Oh, no. Yeah, they're pretty much the backbone to a lot of the code that I write.
Exactly, yeah, because you need to have smarts, right?
Yeah,
Software needs to have smarts. The if-else statements are what give it smarts. It allows it to say, is it this? Yes, then do that. If not, well, is it that? No, well, then do this. That's the sort of stuff that we build into our code so that programs can actually do something useful. If we didn't have that, programs would essentially be limited to printing things. Mm-hmm. That's not great.
That's no fun.
That's no fun.
No choices would be made.
Yeah. But Dale, you know what is fun? Whenever you come on and you show us your code. What do you want us to play with today?
Today we start with reading from a text file, the contents of a text file, and then we will take what we pull in and turn that into a list, essentially.
Whoa, wait. This is brand new. You actually, you want us to take data from outside the program. We hadn't been doing this before.
You could do that?
Yes. This is the fun stuff.
Okay, now see now we're starting to get into something that really permeates real world, because previously, all the data was either coded into the program or was this something that you entered in real time.
Right.
What Dale is showing us now, and that's why I'm bringing this up, is important because it allows your program to act on data outside the program.
Ooh, interaction with other fun things.
Yeah. So Dale, show us how this works.
All right, so here's the text file I've got. It's just a couple of Batman DC universe villains
You're big
here.
in the DC. Actually, I was just reading about Deathstroke last night. I'm like, oh, Slade, Deathstroke, yeah, okay.
And so each name is separated by a comma.
Okay.
And that's all I have in this text file.
Comma delineated text.
Exactly. And so the first line here is saying, open this file that I have on my desktop that I was just showing you guys in a state of R for reading purposes only.
Right.
And so that gets assigned to this variable here, text_file. So it just acts as a reference to this text file on my desktop, essentially.
Right. Actually, this is something that's good to point out. There are a lot of beginners who think, oh, this operates like any other variable, so I'm taking the entire contents of text file and putting into a variable called text file. Which it's kind of true, but it's not really. Quite. Yeah, you're creating a pointer. You're creating a reference to where the file is.
Oh.
Right, and almost sort of an object, really, because you can then have functions that you can use on it. And so I'm using the read function, which will read the entire contents as a string into this new variable.
And now it actually is in a variable.
Yes.
So is that why you included the R on the first line?
That's correct.
Okay.
That's correct. And there are other arguments that you can use for that I guess we'll cover a little later. But I mean, another argument you could use for that is it's a W, RW, it's
Yeah,
a reading
yeah.
and writing.
Read, write.
Oh, cool.
Right.
Yeah, so actually, you're a Linux girl. You know
Yeah.
this. These are all those little mods that you can add at the end, right?
Yeah, that's super fun.
Is it read only? Is it read write? Is it write?
Execute.
Right.
You fun.
Right.
Now, actually, Dale, we got a good question in the chat room from M5. He wants to wonder, well, what's the limit on the file size? I mean, how big of a file can you read into a text variable?
I imagine there is a file size limit on that. I don't actually know what it is off the top of my head.
And you know what I would say to M5? I would say, how about this? Break it and report back to us with how big of a file you needed.
Totally.
See, you made work for yourself.
I'll try that too.
So M5, go onto our Google Plus page today and tell us how big of a file you had to push in before your computer said, I ain't doing that. All right, I'm sorry. Go ahead.
Yeah, totally. So at this point, we take our string variable here, and then we put split on it, which will then use the comma as a delineator, and now separate those names that I had comma separated into a list now that we can iterate over.
Nice.
So you name that foes.
Yeah.
Okay.
And so for faux in foes, here's like one sort of for loop where you can kind of just take the list and then grab each element as it goes over it.
Right.
So
the range will be as many entries as there are inside that list.
Right. It'll go that far and no more. So for faux in foes, so if foes, so each time it goes through, if foe is Joker, print why so serious.
Oh, that's awesome.
Else, just print the name of the foe. Just print foe.
Oh,
So
okay.
in your for loop, and you did a simple for loop, you had an if-else statement that basically said, I will do something unique if it's Joker, otherwise I'll just print the name of the foe. But you could just as easily put a bunch of elif statements, right, the else if. So you could have said, if Joker, if Deathstroke, if, I forgot Penguin or whoever else you had in there, and each of those could have had their own unique print statement.
That's
That's
cool.
correct. But here it is as it was written, and there it is. Joker, I'll pull up the text file so you can see here.
Okay, so the first one is Joker. Since it is Joker, it prints out why so serious. Else, if it is not Joker after that, it prints out
Bane,
just the name.
Clayface,
Bane, Clayface,
Deathstroke.
Deathstroke, and then tells you to exit.
Now, this seems incredibly simple, but of course, the reason why you're doing this is because you are showing us, again, one of the most useful things a computer program can do, and that is to take in external data, do some sort of processing on it, right? Compare it to a list, give you some useful analysis. That's exactly what his does. He could have, as M5 said, he could have that huge file. He could have 2 gigabytes before he starts getting an overload in a 32-bit memory allocation system. And it will search through the entire file for Joker. And Joker is the only one that it will replace with why so serious.
Okay.
Right? So, I mean, again, very simple program, but I think if you start imagining past just what you see on the screen, you see how useful this can be.
Yeah.
Got it.
Now what I want to see is him put in a whole bunch of other printout statements, outputs, for each of the other names.
Yeah. Now, why so serious? No, sorry. No, actually, Dale, one of the things, if we could go back to your code, one of the things that I'd love for you to explain here, I know people are going to get lost a little bit when they get to the foes equals text from file dot split function. So you explained it. So what it's doing is it's looking through the text file, which, by the way, you read into the variable called text from file, and it's looking for those commas, and it knows those commas are the delineating feature. So that's the end of one entry and the beginning of the next. But can you explain how does this work? So we know that split is a built-in function. Foes is what? Foes is just a variable that comes from text from file dot split function?
Right. Foes is the resulting list from the split function.
Oh, okay, I get it. So text from file dot split gives you a list built off of the entries that were divided by the comma, and then in the for loop, you just say from foe in foe. So the number of entries in the list, we compare each entry, see if it's Joker, and then increment.
Right. Yeah. It doesn't even. It's not even really looking at the number of entries. Really, it's just looking at the list itself, and then treating each index, as its own string, and then just kind of just going over them. It's not really doing it numerically. It's just kind of just going as what are the contents of this list.
Right. So it just keeps going until it runs out of things to look at.
Right.
Until it gets bored. Right.
Until it gets bored.
All right, Dale, now let me ask you this. We gave them these really, really simple examples of bringing in data from a text file. We gave them really simple examples of for loops and while loops and mods and if else. As our code warrior, what would you like to see out of our audience? As they start coding, as they start taking these lessons, and they finally have something really, really juicy to sink their teeth into, what would a challenge be that you think is their level that they could do that maybe challenges them a tiny bit?
Well,
challenge me. Challenge me, Dale.
Let's see. How about...
Give me homework.
Let's see. What do I have here?
I can see the wheels turning. He's getting diabolical.
I know that I'm going to create a text file for next week.
Right. So obviously we need a text file.
Where does the text file have to go? Does it have to go on your desktop, or can you put it wherever?
Well, you get to define the path.
You can just
if you go ahead and look at his code again.
Does it have to be under a directory under users?
Oh, it could be anywhere. You just have to tell it. So this is in the directory users, in the directory Dale Chase, in the directory desktop, and on the desktop a file called text_file.txt. So as long as you know where it is, you can put right there where it's going to find the file.
Okay.
Precisely. And so, all right, so now you've given me the idea.
Oh,
all right, so
here we go.
Yay.
So use your text file as sort of a configuration file for a program.
Ooh.
So use your text file to load data that your program will then already know to be true. Oh. Like, let's say, let's say, how about like, what do you call it when you localization, right?
Right.
So,
okay. Good.
So let's say you make a simple calculator, but your addition and subtraction string comes from the text file.
Okay, yeah. I like that. Okay, so what he's saying is you're going to create a program that is going to go ahead and pull in data from outside. So it's going to pull in, have a text file full of numbers, okay?
Okay.
And you need to do something using all that we've taught you so far on, first of all, inputting that data, getting into some sort of readable form, then making sure that they're actually integers, right? Remember we had
so do some sanitizing.
You got to sanitize. You're probably going to have to run, you're definitely going to have to run a couple of loops here to get all that data in.
Right.
And then you're going to run a series of calculations. You get to choose what kind of calculations, you get to choose how it's going to be outputted, but you need to give me some sort of unified piece of data at the end that comes from the text file.
So that's 4 to 5 steps.
4 to 5 steps. Well, and that uses pretty much everything that we've given you so far.
It does. That's fun. I like it.
Dale, you are an evil man. Now, I know for a fact that you have been sort of itching to get into something that you've been playing a lot with, and that is using Python with YouTube. What are you going to be showing us in the future?
Maybe just grabbing some basic data, using just some HTTP requests. Or if you want to get into installing libraries, we can try that.
Ooh.
Yeah, I'm thinking that we may have to hold off on libraries just a tiny bit, maybe a later episode. But I would love, now that we've given them a way to get external data, let's also show them how they could access something from YouTube. And I'm going to leave that up to you. So I'll leave that for you, Code Warriors, Code Monkeys. This is what we've got coming next week. Dale Chase from Discovery Digital Networks, thank you so very much for being with us. Now, I don't know if our TD has a little bit of your beats marked up, and now would be a good time to start playing it so that Dale could tell us what he does, where we can find him, where we can hear this groove.
Yeah. So when I'm not coding, I'm making music with collaborators like Shannon and Dual Core, and I've got some joints on Bandcamp, dchase.bandcamp.com. The joint you're hearing right now is off of my most recent full-length type def.
And by the way,
Something
folks,
for the internet.
You're not mistaken. That is Dale Chase and Steve Ballmer moving out. Big money.
Yeah, that's my bro.
And actually, the song that's playing right now, this is one of the very first songs I heard from your album, and it's kind of smooth. This is what I listen to when I'm coding, folks.
It's good stuff.
Yeah. Dale, again, thank you so very much. Thank you for being our code warrior. Thank you for bringing in these examples each week, just pushing our audience that much more to improve their code foo.
Absolutely. Thank you
guys
so much.
We'll see you next time.
Thanks for having me.
Peace.
Now, folks, that's a lot of stuff.
That is a lot of stuff.
That is a lot of stuff.
But not as complicated as it sounds.
It really isn't. No. That's what we've been doing. We've been giving you a little piece each and every week that will make the next piece a little bit easier. So hopefully you've watched all the episodes of our Python module, and hopefully you've also watched our episodes of C#, because again, they build on each other.
They do, and we explained a lot of these in detail, like variables and, you know, using all these different types of things when we were doing our C# module. So a lot of the explanations that we're kind of skipping over during Python, you can find in that module.
Yeah. Now, of course, if you're freaking out, the best place to go would be to our show notes page.
Yes,
you can find us on twit.tv/coding. And what you'll find there is not just all of our episodes, not just a way for you to automatically download each episode into your device of choice, but you'll find very detailed notes of what we covered each and every single week. We put all the examples that Snubs brought up and Snubs compiled. We give you a link to a GitHub that actually contains the code, actual copy of the code from Dale, which means you don't have to write this stuff down. We want to give it to you. We want to make it easy for you to start coding.
Absolutely. Yeah, make sure to check out that GitHub because that link has everything that you'll ever need.
Boom.
Also, we are on iTunes still. Apparently, we're still one of the top podcasts, which is crazy.
I don't know what's going on.
People are watching this show. It's so weird.
We like knowledge.
And if you guys use Android too, I just figured out that we're on Dogcatcher as well. You can search for us on there too. Just search for Coding 101 and we'll pop up. So make sure to give us a rating.
Yeah, please do. And also, you know, as long as you're going to give us a rating, why not jump into our YouTube page as well at youtube.com/twitcoding101. Again, you'll find all the episodes.
Look, we have 1,700 subscribers.
Exactly. But,
Yay.
you know, more important than all those episodes, we're also going to, you get a nice entree into our G+ page, into our community page. It's all something that we're trying to create. We don't know exactly what we're going to be doing with it yet, but join, be part of the community, and help us figure it all out.
Absolutely. And again, that was gplus.to/twitcoding101. And you can see all those different comments that we've been receiving from everybody who's been sharing their code. Very, very helpful for each and every one of you.
Yeah, and be sure to send us those coding examples because you've seen we use them on the show. You know, it's like pinning up your homework on the refrigerator.
A+.
Yes, and oh, by the way, if you're not into the G+ groove, I get it. I understand. You don't want to be in yet another social network, but you could also find us on the Twitters. That's right. Find me at twitter.com/PadreSJ.
And I'm twitter.com/snubs.
When you follow us, you also get a free toaster.
Free toasters. I am a Cylon.
But, you know, I think that's about it. You know, it's been a full week. We'll see you next week with some brand new stuff, including some YouTube integration.
Fun.
Go ahead and play with your parsing, bring in those text files, and show us your code.
Right. You got a week.
You got a week.
Do it.
Until then, I'm Father Robert Ballecer.
I'm Shannon Morse.
And